Okay, you guys, I don't know who else is like me who has the AP CSP exam tomorrow, hasn't studied, searched up a bunch of YouTube videos about it, and couldn't find anything. Really. All the stuff I found is like from 9 years ago, 8 years ago, and like I feel like some people just don't really explain it. So I'm thinking we do this community thing, and I'm really praying that this video gets to you guys in time. So I'm thinking we do this thing where I'll go through the units, I'll say what I know, you guys in the comments can add on, and like we'll do this like mutual study thing. If that works, it works. If it doesn't work, the algorithm doesn't work and doesn't send it out to you guys. Algorithm? What a funny word. Anyway, doesn't send it out to you guys. Good luck on your AP tests. I know you guys will probably do well because if you're out here studying and looking for videos, or you're just really cooked and need to learn it like ASAP, but it's okay, guys. We've got this. Okay, so we're gonna start with digital information. I'm looking at something for like a reference so I know like what to mention to go by. So, okay. So, binary data, ones and zeros, also known as bits. We also know that 8 bits make a byte. And how we read it, which tripped me up on some tests, I need a pen and paper. So, excuse me, I'll be right back. By the way, I'm making this video like unedited because of the lack of time that we all have. So I apologize. Sincerely. Index card, I guess. And pajama pants, of course. Okay, so basically, I'll just write this out. So it's like this. And we read, instead of us usually reading like left to right, we're gonna read right to left. Okay, so then I'll multiply these all out so you guys can see it. Memorize this if you don't know it already. If you do not know how to do this already, memorize it. I am telling you. Because you're gonna need to know how to do this. I know that for a fact. So, 2 to the power of 0, 1, 2, 4, 8, 16, 32, 64, 128, 256. That is how it works. Okay? And ones and zeros can represent things like choices, like on and off, right? When you have all of those ones and zeros together, 8 of them, that is a byte, and multiple bytes together can represent anything from like numbers to letters to symbols, anything like that, okay? So let me just, oh, colors. The RGB thing that has like a bunch of colors. I still haven't quite figured that out, but I'm praying that it comes to me, you know? The stuff that I've practiced on the practice exams weren't that hard. It was basically just know how to do this, know what they multiply out to, and multiply that out, and you will get the numbers that are represented. Because what I saw, let me give an example. It was like parentheses 78, comma 0, comma 255, and you need to know how many bits into like 1 byte represent that number. That's what you need to know, I think, for the RGB things. I'm not entirely sure. I haven't taken the exam yet. I'm a first timer like the rest of y'all. Like, this is my first year taking AP exams. This is my second one. I took the one for Gov, actually, before this. So, bear with me here. And then, how I said zeros and ones represent the on and off. So, let me show you. It's like 0, 1, 1, 0. I'm gonna hate multiplying this. 0, 0, 1, 1. Right. Okay. So I don't know if this shows it inverted for you guys, but I gotta double check. This is my left. Oh, wait. I swear if one of these falls out right before. Yeah, this is my left to right. So I'm looking at this right here. This is my starting number because, yeah, it's going right to left. I don't know if it's inverted. I'm looking at it weird. Okay. So this represents like an on kind of thing. So that means this first number here, I'm using that and I'm adding it. So 2 to the power of 0, 1. So I'm going to write down like 1. And the next one is like 2 to the power of 1 because there's a 1 here. So 2 to the power of 1 as you can see that I wrote it out, is 2. 1 plus, I'm going to put a plus there so y'all don't get confused. 1 plus 2. That right there. And then 0, 0, 0. These 3 numbers, we just ignore them. We're not adding them in. If you want placeholders, put plus 0, 0, 0. Okay? So, we're up till the 5th byte. And then we have, let me look at this again. 0, 0, 0. 32 and 64. So we're going to add 32 and 64 to the mix because they're the ones. Plus 32 plus 64. And there's a 0 here, so we ignore that. Okay? Always remember, it doesn't start from 2 to the power of 1. It starts from 2 to the power of 0. Which is why when I go up, I'm only looking at 128, which is from 2 to the power of 7. Right? But it does, like, if there are more... Yeah, I don't know if I'm making sense. I hope I'm making sense, guys. If I don't, comment down below. I'll clarify. If I can. If not, somebody else who's taking this course who knows the stuff, also, you can help comment. You can help clarify. You can help add details. Okay. So 64 plus 32 plus 2 plus 1. I'm hoping I'm doing the math right. If not, holy Orlos. Okay. So that's 6, 8, 9. 6 plus 3. 99. Okay, that's what you get. That's what this represents. Okay, so I got that. Let's go on to see what else they have here. Oh, okay. That just brought me to my assignment that my teacher assigned, which isn't that helpful for me to do. Okay, I got that. Okay, so on here, it has, like, what can be stored in a single bit. I don't think they're gonna ask that, but if they do, a single bit, like, only one of the ones and zeros, it's like a yes or no type of thing, on or off. That's all you need to know. Bytes, I got that. Let's see here. Okay, now that's all zeros. Oh, another thing is like, you know it's an odd number if this, right, if there's a 1 here, because that 1 represents 1. So it's going to be an odd number. Oh, yes. Okay, the number limits, overflow, and round off. So I'm pretty sure, and I will, like, look at this after to, like, double check. I'm pretty sure a round off error is when the program that's running rounds the number wrong. And I think it's because, like, some things run it, like, if you have 1 over 3, 0.333333, and it'll, like, 0.333334. I think overflow is when basically, and I feel like we might see this on the test, it's when, say we have, like, what do I want to do? I'm gonna make this easy. A 3-bit system. You are not gonna find this anywhere. If you have, like, a 3-bit system, right? So the most amount of, like, numbers that 3-bit system can hold is, like, 7, right? So if you have, like, something that's, like, 1111, and that's, I'm doing the math, 15, you're gonna go into an overflow because the computer can't handle that number, right? And it's basically like what a lot of people said, it's like a meter thing, and if your car can go a certain amount of, like, miles, and then it just hits an overflow, it goes to 0 even though it's not 0, is what I think that is. Okay. So let me see what this says so I can double check what I told you guys, and you guys can also, like, correct me, add more on. Okay. I think I got overflow pretty good. Oh, what I was talking about the 0.99999 thing, That is a floating point. Oh, something like that. Yeah. Okay. I think I, for the most part, got that. If you guys don't think I did, definitely comment down below, like, the correct thing and correct me. Because, like I said, I'm learning just like y'all. Storing text in binary. I haven't seen any questions with this yet, actually. If they do come on, there should be, like, a chart or something to show you guys, but I don't think it's gonna be there. Analog data. Okay. So what I know is that it's like data that changes constantly over time, continuously over time, and it can be things like sounds is the most common one. So like music, people talking, birds chirping, something like that. I'm pretty sure that's analog data. If I'm wrong, check me 100%. Sampling, the more sampling you have, the more accurate your like sample is going to be. I'm pretty sure. Again, if I'm wrong, check me. Let's see here. Oh, okay. So this comes from, because I want to give credit, this comes directly from Khan Academy in the words of the article, because I myself did not remember that. The number of bits per sample is known as the bit depth, right? Okay, so basically, in what I'm seeing, it's like this isn't the exact number. So the digital data is getting coded into a binary sequence, and you can see it's 4 bits per, like, yeah, that's apparently a bit depth. I don't think we're gonna need to know that. If we do, that's wraps for me. Okay, so I'm pretty sure we got that. Let's see here. Oh, compression. Lossless and lossy. This took me a really long time to get it, and if I still don't get it, I apologize, guys. Again, correct me. So I'm pretty sure lossy is when you have like a permanent loss when you compress your files, and it's irreversible. Lossless, I'm pretty sure you can revert it back to the original. And there was this one example of it. I'm not sure. Like taking out things that can't be heard by the human ear. I'm gonna search this up real quick. What type of compression is used when I'm thinking that might be lossy, but I'm not sure. Okay. Yeah, when you remove frequencies that the human ear cannot normally hear, for example, very low below 20 Hz, this is coming from Copilot Search, this is not my words. You're applying lossy compression. So basically, yeah, what I said earlier, that's right. Okay. Yeah. So let's look at this. Oh, okay. So this is apparently an example of lossless text compression. Which, yeah, that makes sense. I just never thought of it like that. When there are words that have a lot of repeating things in it, like you have banana or something, you can replace like the A in the end with like a symbol or something, and that takes up like less space. That's lossless compression because you can revert it back to what it originally was. Okay. I'm pretty sure I did see some practice examples. I mean, some like practice questions of this when I was doing the one of the practices. So I would say, yeah, look over that. If you don't really know much about it, I would say review it. But I don't think it's that big of a thing. I hope. I think, guys. Um, let me see here. There's something called RLE. I've never heard of it in my class, so I don't know. And I also haven't seen any like practice questions on it when I was taking the practice test. But quoting directly from Khan Academy's article, it's like used for compressing fax machines still use RLE for compressing the fax documents since they only need to represent black and white letters. JPEG images do use RLE during the final stages of compression, but they use a more complex algorithm to decompress the photographic details. I don't know. I do not think that's going to be on the exam. Let's see here. Yep, so we got that. Okay, let's see. Lossy. I think I pretty much hit the thing on lossy compression. A common example that I've seen during a lot of the practice tests I've taken was definitely the sounds that a human ear can't pick up on, frequencies. That was definitely a common one I've seen. Absolutely. Okay. Copyright. Okay, so basically, copyright is basically the licenses people have on how others can use their work. If I remember correctly, Creative Commons, I think, is when someone has a license that other people can use their work as long as they add on like their own like creativity to it, their own like pieces to it. I'm pretty sure the stuff under Creative Commons you can't sell. Let me search that up real quick. Yeah. Wait. Oh, I was wrong about that. This comes from Copilot Search, not my own words. Creative Commons content can be used commercially if the license does not include the non-commercial restriction and proper attribution is provided. Okay. So, I guess you can. My bad. Um Okay, so there's fair use. I completely forgot the definition of that. Okay, so it allows limited, this comes from ChatGPT, allows limited use of copyrighted material without needing permission from the copyright holder. Examples are quoting parts of a book, using clips, parodying a song or movie, I've seen that a lot, or academic or classroom use within limits. What is not automatically fair use, and I feel like we all know this, is when you like take something and just give credit to the original creator. Or using only like a short clip, I guess. I don't know, man. I had to double check what license Khan Academy is under because I was scaring myself. Anyway, Creative Commons attribution. Yeah. Okay. Okay. So anyways, do not think we need to know the Digital Millennium Copyright Act. Yeah, so if you want to, you can look more on that. I'm not going into it because I don't think it's necessary. Creative Commons, like I've said, you add on your own original content to it. Open source, I'm pretty sure anyone can use it. It's online for the public. We know that's open access. Ooh. Hold up. What is the difference between okay. Open source usually refers to software or code. This comes from ChatGPT. And open access comes from things like research papers, articles, educational materials. Okay, so I was basically right. Anybody can use it if they want. Yeah, I think a good one to know, Creative Commons. I did see questions about that when I was doing practices. And that is the end of part 1. I'm going to make a video for part 2 as soon as I publish this. So comment down below anything you want to add on, any questions you had, just anything.